Here is something that will quietly rearrange the furniture in your brain if you let it sink in properly. The speed of light, 299, 792, 458 meters per second, is not a rule. It is not a restriction that someone built into the universe the way engineers build a governor into an engine to prevent it from running too hot. It is not a cosmic regulation waiting to be worked around by sufficiently advanced technology or sufficiently clever physics. It is something far stranger and more fundamental than that. The speed of light is a description of reality's geometry. It is what falls out when you do the math on the shape of the universe itself. And the moment you genuinely grasp that distinction, not as a phrase you've heard, but as something you actually understand, everything you thought you knew about time, about space, about the difference between past and future, reshapes itself around this single number. Let's start with the thing that confused everyone for decades before Einstein arrived to fix it. You throw a baseball standing on a moving train. The train travels at 100 kilometers per hour. You throw the ball forward at 50 kilometers per hour relative to your hand. Someone watching from a platform outside sees the ball moving at 150 kilometers per hour. The speeds combine. This is intuitive. This is how physics worked for centuries, elegantly and reliably. And nobody found any reason to question it, because in ordinary life it always turns out to be right. Now do the same thought experiment with a flashlight. You're on the train. Let's say it's moving at half the speed of light, which is not an ordinary train, but stay with me. You click on the flashlight, the beam shoots forward. Here is the question. How fast does someone on the platform outside measure that light moving? The answer, according to every experiment ever conducted, is exactly the speed of light. Not the speed of light plus the speed of the train. Not a single extra meter per second from the train's motion. The train's velocity contributes precisely nothing to the light's velocity. You could be going at 99% of the speed of light, or 99.999%, and the beam from your flashlight still races away from you and past the platform observer at the same number. Always the same number. This is the thing that wrecked the existing picture of physics in the late 1800s. Not because anyone wanted it to be true, because experiments kept insisting it was. In 1887, two American physicists named Michelson and Morley built one of the most precise measurement instruments of their era, specifically to catch light behaving differently in different directions. The logic was airtight. The Earth is moving through space. If light has a fixed speed relative to space itself, then light traveling in the direction the Earth is moving should appear faster to us than light traveling perpendicular to our motion, exactly the way running toward an approaching car makes it seem to close the gap faster than if you're standing still. They measured. They recalibrated. They measured again in different seasons when the Earth was moving in different directions through its orbit. Nothing. Light moved at the same speed in every direction, regardless of how the Earth was oriented. The expected difference wasn't there, not partially there, completely absent. This result was so disturbing that physicists spent years trying to explain it away. Maybe space drags along with moving objects, maybe measuring instruments contract in just the right way to cancel the effect. Every proposed explanation was elaborate and uncomfortable. The universe was clearly trying to tell them something, and they kept refusing to hear it. Then Einstein heard it. He was in his 20s, working a day job in a patent office in Bern, and he had the unusual intellectual habit of not accepting confusion as a permanent condition. His question, stripped to its core, was this: what would have to be true about the universe for light speed to be constant for every observer, regardless of their motion? The answer he arrived at was magnificent and deeply strange. Time and space cannot be the fixed, absolute backdrop everyone assumed. If light speed is going to stay constant for everyone, the universe has to be willing to bend time and stretch or compress space differently for different observers. The constant isn't time, the constant isn't distance, the constant is light speed, and reality will do whatever geometry requires to protect that constant. This sounds abstract, so let me give you the thought experiment. Richard Feynman loved to use to make it concrete. Imagine a clock built from light. Two mirrors facing each other, separated by a fixed distance, with a single photon bouncing back and forth between them. Every round trip is one tick. Because light speed is constant and the distance is fixed, You can calculate precisely how long each tick takes. It is a perfect clock. Now put this clock on a moving spaceship and watch it from the ground. From the ship, the photon still bounces straight up and straight down, nothing unusual. But from the ground, watching the ship slide past, the photon isn't going straight up and down at all. It's going diagonally up and forward, then down and forward, tracing a zigzag path rather than a vertical one. The diagonal path is longer than the straight vertical path. Here is the critical point. Both observers measure light moving at the same speed. That's the whole discovery. So if the path is longer from the ground observer's perspective and the speed is identical, then the time between ticks must be longer as seen from the ground. The clock on the ship is running slower, not appearing to run slower because of some trick of perception, actually running slower. Time itself passes at a different rate on the ship than on the ground. And this isn't limited to purpose-built light clocks. It applies to every process that occurs inside the ship. Every heartbeat, every electrochemical reaction in every neuron, every vibration of every atom, everything that constitutes the passage of time runs slower for the moving observer, as measured from the ground. This is called time dilation, and it is not a hypothesis. It is a measured fact that modern technology depends on. Every GPS satellite in orbit is moving quickly relative to the surface of the Earth. The time dilation is small, fractions of a microsecond per day, but it accumulates. If engineers didn't continuously correct for it, GPS navigation would drift by kilometers within a day. The satellites carry their own corrected clocks, running at a slightly different rate than ground-based clocks, adjusted in advance for the time dilation their orbital velocity will produce. We built this correction into the infrastructure of modern life because the effect is real and precise and unavoidable. Particles created in accelerators and in cosmic ray interactions live longer than they should according to their half-lives because they're moving so fast that time runs slowly for them. The extra lifespan isn't puzzling when you account for dilation. It's exactly what the equations predict. Now here is where the geometry comes in, because this is the piece that most explanations skip over, and it's the piece that makes everything else click into place. We experience existence in 3 spatial dimensions and 1 time dimension. You can move north, south, east, west, up, down, and you move through time. In ordinary experience, these feel completely separate. Space is where things are. Time is when things happen. Independent axes. But Einstein's framework and the century of experimental confirmation that followed reveals they're not independent at all. They're components of a single 4-dimensional structure called spacetime. And here is the key insight. Everything in the universe is always moving through spacetime at a fixed total rate. Right now, sitting still, you are moving through time at the maximum possible rate. All of your space-time motion is going toward the future. You're aging at full speed. But the moment you start moving through space, some of your space-time motion has to come from somewhere, and it comes from your motion through time. The faster you move through space, the slower you move through time. These quantities trade off against each other, and the conversion factor between them, the thing that determines the exchange rate, is the speed of light. Think of it as a fixed budget. You have a certain amount of motion available to you through space-time at any given moment. You can spend it entirely on time, aging as fast as possible while holding still. Or you can spend some of it on spatial motion, and the portion you spend on moving through space is subtracted from your rate of moving through time. You age more slowly. If you could spend your entire motion budget on spatial movement, if you could move through space at the speed of light, there would be nothing left for time. You would not experience time at all. For a photon, this is literally what happens. A photon of light travels through space at the speed of light and experiences 0 time between the moment of its emission and the moment of its absorption. From the photon's perspective, if we can speak of such a thing, it is simultaneously born and destroyed. The universe is instantaneous. This is why the speed of light is the ultimate boundary. It isn't a wall you run into from outside. It is the point at which your time budget reaches 0. You cannot go faster than light for the same reason you cannot have less than nothing. There is no such thing as negative time expenditure. The limit is not imposed. The limit is intrinsic to what motion through space-time means. You might ask, what if I just keep accelerating, keep adding energy, keep pushing, eventually reach the limit through sheer persistence? This is where the second piece of the machinery becomes visible. As an object with mass moves faster, something unusual happens to its inertia. Inertia is resistance to acceleration. It's what makes a large object harder to speed up than a small one. As you approach light speed, your inertia increases, not because you're gaining mass in the conventional sense, but because from the perspective of the physics, the energy you're adding to the system through acceleration has nowhere useful to go. The closer you get to light speed, the more energy you need to achieve even a tiny additional increment of velocity. Mathematically, the energy required to accelerate an object with mass to the exact speed of light is infinite. This isn't an engineering problem. There isn't a better engine that would solve it. The relationship between velocity and required energy in relativistic physics produces a curve that approaches light speed asymptotically. It gets closer and closer, but never arrives. At CERN, the Large Hadron Collider accelerates protons to 99.99999, 1% of light speed. The energy budget required to achieve those final fractions of a percent dwarfs the energy required to achieve the previous fractions. Each incremental step toward the limit costs exponentially more. The universe isn't being arbitrary. This is what the geometry demands. Anything with mass is barred from light speed by the mathematics of space-time itself. Only massless things, photons, certain other particles can travel at exactly that speed because they have no inertia to overcome. They exist at the boundary by default. There is a third way to understand what the speed of light actually is, and Feynman particularly appreciated this framing. Light speed is the velocity of causality. Everything that happens in the universe is connected by cause and effect. Strike a match, the flame appears. Fire propagates, wood heats, carbon bonds break. Every event causes subsequent events. This chain of causation is what gives the universe its structure, its narrative, its directionality from past to future. The speed of light is the maximum rate at which cause can produce effect. When you look at a distant star, you see light that left it years or centuries ago. You are not seeing the star as it exists now. You are seeing it as it was when that light departed. The star might not even exist anymore. You won't know until the news carried by light reaches you. Nothing can carry information, exert force, or transmit influence faster than this speed. If something could, the implications would be catastrophic for the structure of reality. Faster than light signaling would allow, in certain reference frames, for information to arrive before it was sent. Effects before causes, answers before questions. The sequence that constitutes time, the sequence that lets us say this happened and then that happened, would become incoherent. The speed of light is the rate at which the present moment propagates. It is the boundary between what has happened to you and what hasn't happened yet. The universe's entire causal architecture depends on nothing exceeding it. So let's bring all of this back to the simple question we began with. Why can't we go faster than light? Not because someone decided to impose a rule, not because our technology isn't advanced enough yet, not because we haven't found the right kind of engine or fuel or exotic material, because space and time are not independent dimensions. They are aspects of a single structure, and that structure has an intrinsic geometry. The conversion factor built into that geometry, the exchange rate between spatial motion and temporal motion, happens to equal the speed at which massless particles travel. It is not that light defines the limit. It is that the limit exists by virtue of spacetime's geometry, and light travels at the limit because it has no mass to slow it below that speed. Time dilates to protect this constant. Space contracts to protect this constant. Inertia grows without bound as you approach this constant. These are not separate phenomena bolted together to enforce a rule. They are facets of a single mathematical truth about the shape of the universe. Feynman spent decades doing what he called taking the world apart to see what's inside. He believed that genuine understanding, not memorized facts, but actual comprehension of why things are the way they are, was available to anyone willing to think carefully and refuse to settle for mystery. The speed of light is the perfect example of a thing that looks arbitrary until you understand the structure it describes, and then it looks inevitable. The universe turned out to be stranger than common sense suggested. Time is not fixed. Distance is not fixed. What is fixed is the geometry of space-time, and the speed of light is that geometry's signature. The number you calculate when you ask how fast the present moment moves through a four-dimensional structure where space and time are woven into one, that's not a traffic sign. That's the fabric.